The American firearms industry has spent 40 years selling you a mathematically bankrupt lie wrapped in carbon fiber and titanium, praying you never discover the brutal, forensic truth before the 2026 supply chain collapse leaves your $3,000 Magnum starving for brass. While the corporate podcast circuit peddles ceramic-coated bolt actions and self-correcting optics to men compensating for degraded fundamentals, they are deliberately burying the most mathematically demanding, quietly lethal, and logistically invincible cartridge ever put into mass production. This is going to infuriate the centerfire purists, but when the big box retailers lock their doors and the modern grid fractures, the tactical aristocrats will bleed out trying to feed their safe queens while the disciplined rifleman survives on a 19-cent rimfire inherited from his grandfather. Number 1. The 22 long rifle. Walk into any big box retailer tonight and watch the condescending smirk of a salesman as his eyes drift to the bottom shelf, dismissing the little orange brick of 22 long rifle as a child's plinker. That smirk is the sound of an industry desperate to erase history. In the archived records of the Boone and Crockett Club, founded in 1887 by Theodore Roosevelt, sit the notarized skulls of 1,000-pound apex predators anchored at short range by single-shot rimfire rifles. These hunters fed their families through 2 world wars and a Great Depression with a single cartridge, dropping game with a 2.9 grain lead, bullet traveling a modest 1,240 feet per second and generating less than 100 foot-pounds of muzzle energy. The centerfire world treats muzzle energy as the sole metric of lethality, worshipping the 1,200 foot-pounds of a 5.56 NATO round while dismissing the rimfire as combat irrelevant. The emergency rooms of every major urban trauma center in the United States tell a radically different, terrifying story. The late Dr. Martin Fackler, founder of the United States Army Wound Ballistics Laboratory, stunned the defensive community when his decades of gelatin research proved the 22 long rifle possesses a terminal lethality wildly disproportionate to its kinetic energy. Forensic pathologists name this phenomenon the assassin's paradox, a brutal testament to the caliber of choice for Cold War intelligence agencies and professional operators. If we dissect the internal geometry of this impact, the physics are as elegant as they are devastating. Because the rimfire projectile is slow and incredibly light, it possesses extremely low sectional density, rendering it inherently unstable the microsecond it strikes human soft tissue. Unlike a high-velocity full metal jacket that drills a clean, over-penetrating channel, the 22 round begins yawing and tumbling instantly, maximizing its surface area and tearing a permanent wound channel that defies its meager bore diameter. The true nightmare, documented by forensic pathologist Dr. Vincent DeMaio in his definitive medical textbook Gunshot Wounds, occurs when this tumbling lead encounters bone. Lacking the kinetic energy to cleanly exit the ribcage or skull, the projectile deflects, pinballing inside the thoracic cavity in a chaotic internal ricochet. It changes direction by 90 degrees, shredding the aorta, lungs, and cardiac tissue in 3 to 5 separate organ penetrations from a single bullet. Surgeons cannot track it, extraction is practically impossible, and the victim rarely survives the operating table. Number 2. The 1/6-inch precision match barrel. Walk into any mid-range precision rifle retailer and the salesman will relentlessly steer you toward a 2-4-inch stainless target barrel, charging a massive premium for an aerodynamic liability. The century-old pitch claims that a longer barrel guarantees higher velocity, a flatter trajectory, and superior accuracy. For a centerfire Magnum burning 80 grains of slow propellant, that pitch holds water. For the 22 long rifle, it is a calculated lie designed to rob the shooter of both capital and ballistic performance. Major General Julian S. Hatcher, the legendary United States Army Ordnance Officer, completely dismantled this misconception on a laboratory chronograph decades before the current Magnum craze existed. Hatcher's 1,947 volume Hatcher's Notebook proves that the 22 long rifle burns a microscopic charge of extremely fast propellant. That powder is fully combusted within the first 13 to 15 inches of bore travel. Every single inch of steel past that ignition point is not accelerating the projectile, it is actively braking it. The physical equation of friction is unforgiving. Once peak chamber pressure is achieved and the expanding gas column begins cooling, the only remaining force acting on the bullet is the friction of the rifling. Modern chronograph studies by Harold Vaughn, the Sandia National Laboratory ballistics engineer who authored Rifle Accuracy Facts, confirmed Hatcher's findings with laser precision. The velocity sweet spot for the rimfire projectile is deadlocked between 16 and 18 inches. Past that threshold, average velocity plummets and standard deviations widen into unacceptable margins. What the industry actively buried is the uncomfortable truth that a 1/6-inch suppressor-ready configuration is the absolute zenith of rimfire engineering. It is shorter, lighter, quieter, and cheaper, yet it produces the highest average velocity and the tightest standard deviations in every controlled empirical test. The shooter who spent extra on a 2/4-inch match barrel paid the manufacturer for the privilege of stealing velocity from every single shot they take. As we approach the 2026 survival paradigm, maneuvering a heavy, inefficient 2/4-inch crowbar through dense brush is a fatal miscalculation. Number 3, 40 grain standard velocity subsonic ammunition. The loudest cartridges on the rimfire shelf carry the flashiest marketing labels. Hypervelocity rounds boasting 1,700 feet per second, promising greater range and tighter groups. Yet, if you walk onto the firing line of any serious NRL 22 competition or Olympic small bore match, you will observe what the top 1% of elite shooters actually chamber. They refuse to touch hypervelocity commercial trash. They load standard velocity or deliberately subsonic rounds locked at 1,000 feet per second because the difference in their 100-yard group sizes is not merely marginal, it is catastrophic. The explanation lies in the inescapable mathematics of the transonic trap, thoroughly documented by Harold Vaughan's Doppler radar research. When any bullet crosses the sound barrier at approximately 1,125 feet per second, it generates a supersonic shock cone. Because the 22 long rifle carries a notoriously poor ballistic coefficient, it bleeds velocity rapidly. A hypervelocity round leaves the muzzle supersonic but crashes through the transonic barrier somewhere between 50 and 75 yards downrange. At that exact transition point, violent aerodynamic buffeting disrupts the bullet's center of pressure, causing the projectile to wobble and deviate unpredictably. But what truly separates this foundational truth from commercial myth is the mechanical toll hypervelocity extracts on precision hardware. To achieve those advertised speeds, manufacturers extend the brass case by approximately 100 thousandths of an inch to accommodate more propellant. When you force that elongated case into the tight match-grade chamber of a high-end custom bolt rifle, the projectile is jammed directly into the rifling before ignition. Pressure spikes violently, extractors shear off, and breech faces pit. The modern precision rimfire community, led by applied ballistician Brian Litz, has mathematically proven that a subsonic load delivers consistently tighter groups at every range past 50 yards because it never enters supersonic flight. It entirely bypasses the transonic zone of aerodynamic instability. The hypervelocity market is an optimization for a problem that does not exist, peddled to amateurs who prefer to buy speed rather than master the discipline of wind calls and elevation holds. Number 4, 40 grain solid lead round nose. In centerfire defensive calibers like 9mm and 45 ACP, the hollow point is absolute doctrine taught by every credentialed instructor from Jeff Cooper's Gunsight Academy to federal law enforcement training centers. The expectation is that the round mushrooms, upon impact, dumping energy, and mitigating overpenetration. When the modern tactical market transfers that doctrine to the 22 long rifle, the mathematics immediately break down. The industry pushes hollow point rimfire ammunition because expansion sells, but the physics of the cartridge vehemently reject the design. Dr. Martin Fackler's exhaustive gelatin work isolated the exact failure mechanism. A hollow point cavity requires massive hydraulic pressure to peel open and expand properly, pressure that is entirely a function of velocity. The 22 long rifle simply does not generate enough speed to guarantee this mechanical action. At the muzzle, a rimfire hollow point might expand inconsistently. At 50 yards, where velocity has bled off below the critical threshold, expansion becomes a dangerous coin flip. At 100 yards, the hollow point effectively ceases to function. This creates two distinct catastrophic failure modes in field applications. First, the hollow point fails to expand at all, behaving as an aerodynamically inferior solid that lacks the penetration depth of a properly profiled round nose. Second, the hollow point expands prematurely upon impacting a tough outer structure like a scapular ridge or rib bone, dumping its limited energy into surface tissue and producing a shallow, non-lethal wound. Dr. Vincent DeMaio's forensic archives confirm this pattern. Shallow hollow point rimfire wounds produce angry, surviving targets, while lethal outcomes overwhelmingly stem from deep penetrating solid profiles. For any genuine survival application where the rifle must perform flawlessly small game harvest, wilderness procurement, or close-range predator defense, the discipline choice is the 40 grain solid lead round nose. It tracks straight, penetrates deep, and drives directly into cardiac and central nervous system tissue with a brutal consistency that a lightweight hollow point can never replicate. The industry wants you to treat your rimfire like a centerfire platform. The forensic data demands that you stop pretending. Number 5. The manual rimfire action. The modern tactical market is currently drowning in AR-22 conversion kits and dedicated semi-automatic rimfires. Platforms like the 10/22 and the M&P 15-22 dominate social media feeds, heavily promoted as trigger time multipliers for AR-15 shooters seeking cheap practice. They are phenomenal range toys, but drag any of these blowback semi-automatics into a sustained, field-grade operational scenario without a cleaning kit, and their fatal Achilles heel surfaces within 300 rounds. The 22 long rifle is the filthiest cartridge currently in mass production, a direct consequence of a 19th century heel-based projectile design that the industry refuses to re-engineer due to backwards compatibility. Philip Sharp, author of the 1937 foundational text Complete Guide to Handloading, documented this structural flaw. Unlike a modern bottleneck cartridge, the rimfire seats its bullet at the exact same diameter as the brass case, leaving no internal neck to hide lubricant. The exposed lead is smeared in a sticky wax to prevent bore leading, a wax that immediately magnetizes pocket lint, sand, and airborne grit. When the round detonates, this wax vaporizes and mixes with unburned propellant, creating a viscous carbon sludge. Because semi-automatic rimfires operate on straight blowback, the rearward gas pressure blasts this sludge directly into the bolt raceway, extractor channel, and firing pin tunnel. Mechanical drag increases exponentially until the bolt slows, stovepipe extractions multiply, and the action entirely ceases. Load a subsonic round into a heavily fouled semi-auto in a freezing survival environment, and the weapon becomes a paperweight. The legendary Colonel Townsend Welland, whose doctrines shaped 20th century sporting marksmanship, hunted his entire life with manual bolt and lever-action rifles for this exact reason. Manual actions run on human horsepower, entirely independent of gas systems or blowback cycling reliance. They offer unconditional, omnivorous reliability across every ammunition profile, from primer-only CB caps to standard velocity solids. As the 2026 crisis looms, the survivalist trade-off is stark. Accept the rigorous cleaning schedule of the semi-automatic or embrace the absolute unstoppable lineage of the manual lever action. Number 6. The rimfire brass casing. The most hated sound in the firearms world is the dead click where a deafening bang should be, the signature failure to fire of the rimfire cartridge. When this happens, the amateur shooter immediately blames the rifle, diagnosing a worn firing pin or an out-of-spec bolt. In the overwhelming majority of cases, the rifle is flawless. The failure is baked directly into the 19th century engineering of the rimfire brass casing itself, a structural compromise that no amount of expensive gunsmithing can ever eliminate. Major General Julian Hatcher laid out the brutal mechanics of this flaw. Centerfire cartridges utilize an independent primer cup and anvil pressed into the case head, guaranteeing ignition when struck. Rimfire manufacturing, refined by companies like Ely and CCI, utilizes a radically different, inherently flawed process. A wet paste of priming compound is dropped into the thin brass case, which is then spun at high RPMs in an industrial centrifuge. Centripetal force slings the wet paste into the hollow rim, an incredibly imprecise method that inevitably leaves microscopic voids, bubbles, and dry spots. If the firing pin crushes an arc of the rim containing a void, the weapon clicks. There is a secondary materials science limitation that prevents modernization. For the firing pin to successfully crush the rim from the outside, the brass wall must be paper thin, typically 4 to 6 thousandths of an inch. This fragility imposes a hard ceiling on chamber pressure, capping the 22 long rifle at approximately 24,000 pounds per square inch. If an engineer attempted to push a rimfire to centerfire pressures of 62,000 pounds per square inches, the thin rim would violently rupture upon ignition, venting superheated gas and brass shrapnel directly into the shooter's eye. This inherent unreliability, roughly 1 malfunction per 1,000 rounds in premium match ammunition, is precisely why no serious instructor will ever validate the 22 long rifle as a primary defensive sidearm. It is a logistical miracle and a magnificent training tool, but it is not a bet-your-life duty caliber. The engineering simply will not permit it. Any marketer or influencer who tells a buyer otherwise is deliberately betraying the thermodynamic and material science that Hatcher and Sharp codified a century ago. Number 7. The takedown survival rimfire. Every internet forum debate regarding the ultimate bug-out rifle eventually devolves into the same tired, recycled argument: 5.56 NATO versus 308 Winchester versus 6.5 Creedmoor. Every single one of those debates completely ignores the most ruthless logistical calculation any infantryman has ever made. The United States Marine Corps operates on a three-word proverb: ounces equal pounds, and pounds equal pain. Over a 20-mile forced march across broken terrain in a grid-down scenario, every ounce of ammunition becomes a fatal liability measured in exhaustion and reduced tactical mobility. A standard M2A1 ammunition can loaded with 500 rounds of 5.56 NATO, weighs up to 16 pounds and costs roughly $400. A plastic brick of 500. 22 long rifle rounds weighs barely 3 pounds, fits inside a standard cargo pocket, and costs under $30. The mathematics are completely unforgiving. For the weight and cost of a single centerfire ammo, a survivalist can field over 6,500 rounds of rimfire ammunition. Paired with a takedown platform like the Marlin Papoose or the Ruger 10/22 takedown, this provides the unmatched capability to sustain a human being on small game for an entire calendar year at a combined weight under 10 pounds. However, this logistical dominance demands a severe skill tax that centerfire shooters refuse to pay. Dr. Franklin W. Mann's 1909 external ballistics research proved that a bullet stabilizes like a gyroscope, demanding a twist rate perfectly matched to projectile length. Push a heavy 6.0 grain sniper subsonic through a standard 1/16 twist barrel, and it will violently destabilize within 10 feet, keyholing sideways into the dirt. Furthermore, a 10 mph crosswind will deflect a standard rimfire bullet nearly 39 inches at 300 yards, while dropping it 4.5 feet below the line of bore. Hitting a 4-inch steel plate at 300 yards with a .22 long rifle is the ultimate diagnostic test of an American rifleman. It strips away the crutches of magnum horsepower and self-correcting optics, punishing poor fundamentals with highly visible misses. The decision to pack a takedown rimfire is not a regression, it is an act of extreme discipline. It is the deliberate refusal to forget what the tactical market has spent 40 years burying, choosing instead to stand guard over the mathematical perfection that originally conquered this continent. The centerfire purists will flood the comments with ballistic gel charts from their favorite sponsored influencers, desperately trying to justify the thousands they spent on tactical crutches while actively ignoring the forensic reality of the rimfire. Let them bleed their wallets dry, preparing for a war they cannot afford to sustain, while the disciplined few quietly hoard the mathematical perfection of the caliber that actually built this continent. The 2026 paradigm shift will not be televised, and it will not forgive those who traded historical lethality for polymer marketing. Stay vigilant.